Hey guys, this is just a quick little distributive property video. Please refer to these examples as you complete any assignments. Let me know if you have any questions. The root word to distributive property is distribute, and to distribute means to give something out to a group. A lot of times the example I like to use is if I brought brownies to class, you guys would want me to distribute them equally. I would give the same amount of brownies to each student. I wouldn't give them to one student and not to the others. So to distribute means to give something out, but more importantly, it's to give it out to a group. The next type of example I like to give is I like to give high fives. So we're going to have a little story where there is a detective, a police officer, and a robot. So they are all together. So which means if they're together, we're adding them. And they're a group, so we're going to put them in parentheses. Now, since I like to give out high fives, we are going to be distributing our high fives to each of these people. So what would happen is that your high five would go to the detective, and a high five to the police officer, and a high five to the robot. So what this means is that the high five and the detective are together. Oops. And a high five to the police officer, and a high five to the robot. Notice that every term within our group here, everyone gets a high five. There's now 3 high fives because there were 3 terms. You always want to make sure that you are distributing what is outside your parentheses to each item inside the parentheses. To use the distributive property for mental math, all we need to do is take our traditional math problem, which normally you would solve by writing 56 times 6, and then you would do 6 times 6, and then 6 times 5, and you'd write it down here. We do not want to do that, though. Instead, we want to do it strictly with mental math. Now, we can write some of the information down, but all the multiplication will truly be happening in our head. So what we're going to do is we're going to split 56 into a nicer number to multiply. And by nicer, I mean numbers that we can do in our head. I don't know my multiples of 56, and I'm guessing you don't as well. So what we're going to do is instead of 6 times 56, we're going to do 6 times 50. Oops, pen got a little out of control there. 6 times 50 plus 6. Okay. Because now we know how to do 6 times 50. That's 6 times 5 with a 0 on the end. And we know how to do 6 times 6 because that's a smaller number. So when we are doing all of these multiplications, we want to write them down. So we're going to do 6 times 50 because we're distributing into our parentheses plus 6 times 6. So all I did was I took the 6 on the outside and distributed it to 50, and the 6 on the outside and distributed to 6. And now I can go ahead and simplify. 6 times 5 is 30, and I bring down my 0 because it's not 6 times 5, it's 6 times 50. And 6 times 6 is 36. 300 plus 36 is 336. And that's all I need to do to use it as a mental math strategy. Okay, and again, we can also use the distributive property to help us multiply in fractions. In the past, when we multiplied fractions, we would have to take this mixed number and make it an improper fraction, and then we'd cross-simplify, and then we'd multiply our tops, multiply our bottoms, and then we'd get an improper fraction, so then we'd have to make it a mixed number, and it was a pretty big process that had a lot of area where we could make some errors. With the distributive property, it's less likely that we will do that. So this is how we're going to do it. We need to think of 2 2/5 not as one number, but as 2 numbers put together. The simplest way to break that apart would be to do 5/6 times 2 plus 2/5, because this way we're multiplying a fraction and a whole number, which usually goes well, and then a fraction and a fraction times a fraction. So we're going to distribute our 5, 6 in. So we would have 5, 6 times 2. I'm going to go ahead and put that 2 over 1. And then we're going to have plus 5, 6 times 2 fifths. So we make sure that we can distribute both of those, 5, 6 times 2 and 5, 6 times 2 fifths. And then we can go ahead and try to cross simplify here. I know that 6 can be divided by 2, and that is 3, and 2 divided by 2 is 1. So I get 5 times 1 is 5 over 3 plus, over here again, 2 divided by 2 is 1, 6 divided by 2 is 3, 5 divided by 5 is 1, 5 divided by 5 is 1. So now when I multiply on this side, 1 times 1 is 1 on top, over 3 times 1 is 3. Since our denominators are the same, we can go ahead and add these two together. So if I add them, I'm going to get 6 over 3, which, if I simplify, that equals 2. Okay? So remember, when using distributive property in fractions, just take your initial mixed number and you want to split it so that you have a whole in your parts. So I had 2 wholes, and then my 2 fifths was my part. And then I distributed my 5, 6 in, and then multiply fractions like we know how. Add, make sure that you have a common denominator when you add, and then simplify. Our next example is the distributive property with algebra. You'll notice in here that we already have a problem set up in factored form. It's 7 times, and we have an addition problem in here. So what we need to do is, just like with our brownies or our people example at the beginning, we need to distribute our 7 in. That is distributive property. So when I go ahead and write this, I'm going to write it as 7 times 8 plus 7 times y, giving each of those terms. If you remember when we identified parts of an expression, those terms are usually divided by that addition and sometimes a subtraction sign. Each term now has a 7 of its own, so we're going to go ahead and simplify as much as we can. We can do 7 times 8, that is 56, and 7 times y, well, since we don't know what y is, we leave it as y, and it just is 7y. I can't simplify any more than this, so this is my final answer. Our next example here is another one using algebra. You will notice that we have more terms inside of our group here. Instead of just 2 terms, this time we have 3 terms. Same thing applies. Distribute that 4 on the outside to every term on the inside. So this will look like 4 times n plus 4 times 4 plus 4 times 7n. And then we need to simplify, so we know that 4 times n would just be 4n plus 4 times 4 is 16 plus, now this is a tricky one, it's 4 times 7 times n. So sometimes students think, well, we can't combine with that, but you can, because we could use that associative property to kind of which multiplication do we do first. So we can do the 4 times 7, and that is 28 times n, so 28n. Now in the past, we distributed, we simplified, we're done. Except this time, while looking at what we have here, we always want to make sure we check for like terms. Like terms are numbers that are of the same value, so if they're whole numbers or just a constant number, we can combine those. Otherwise, we look at those variables, and if they have the same variable, then we can combine them as well. Since we have a 4n and a 28n, those are both n, so we can combine them. It's kind of like having $4 in your pocket and then later on getting $28 more. Well, you wouldn't say, oh, I have $4 and then $28. You would be adding those together. So if we have 4n plus 28n, we want to make sure we pay attention to what that symbol is telling us. Is we're going to be adding the 28n and the 4n, which would be 32n plus, we bring this part down, 16. Now our answer is as simplified as possible, and we are complete.